some of the challenges we have is bringing together all the different inputs from companies that all have their specific backgrounds in industrial communication, in networking over the last 10, 20, 30, even 40 years. And the one rule that we have is not reinvent the wheel. So somehow we look into what has been done already, what is useful to reuse when we create the OPC UA FX solution. But at the same time, we need to look forward. What are the industry needs in the future? What is the end user expectation of this solution we deliver? And that's why we cannot just look back and bring together, merge what is in the market today, but look into a modern approach, because the goal is overall to do the field-to-cloud interoperability. So we are not creating a solution just for field level. That's why we take all the concepts of OPC UA with the modeling, with the built-in security. This is a key challenge. Another aspect is also identify what is common with other SDOs in the industry. For example, we all use Ethernet technology as an underlying technology. We use time-sensitive networking or advanced physical layer. There we cooperate with other SDOs to make sure we are not building, let's say, a special ecosystem, but use harmonized standards. This is another important element.
So I've been involved with FLC for several years already. I think this face-to-face workshop was quite important and effective in terms of moving progressing in different areas for C2D, so control-to-device communications. So until, let's say, recently, a lot of the work of the experts were focused on control-to-controller communications, and this is creating a really good foundation to go forward with control-to-device. And here we're finally making very good progress in this area, in my opinion. As well, we have some additional device makers that are participating. I think this is a really good approach and good step to involve and get additional support from the community. So one of the responsibility of the architecture working group is to organize the technical work and an overall framework of the specification. And I think we are trying to make better planning overall to make sure that we are able to deliver solutions in a good stepwise fashion. So we are spending with a lot of time with other participants to make sure that we are prioritizing correctly and we are able to build really solid technical foundation that we can deliver solutions to our customers in a step-by-step fashion.
My highlight is that we could see that the individual groups, they focused on disciplines, like we have the motion, we had the instruments, we had the IOs, right? And it was clear that at one moment of time, things have to merge because there is common interest. Okay, or let's say there shall be common specification in order to ease it. And we are right now on the starting block, to create this common base. And I think that even people say, you know what, we make extraordinary meeting. We do a step in addition in order to promote that, in order to speed up, is for me the sign that not the people are looking at their own and say, look, this is exactly what I want, but that they look around or outside of their borders, and they really want to foster the specification in such a way that it can happen rapidly in order to become public. Our task, so Ken and mine, is exactly on the one hand to steer it technically, and there I'm very, very happy to have Ken on my side. And I am the one who shall more organize and say, look, how can we schedule individual blocks, work blocks, such as that there is no overlap or that there is, allowed to say, no infringement one to each other, so that it can go smoothly, with the objective that really in 2025 we make first steps, but that we make major steps in 26. Whatever will happen is dependent on the group. I don't want to promise too much, but I can tell you one thing. We work hard on it and we strive to bring in something very substantial in 2026.
So the base facet specification describes the core pieces that all of the other working groups, so motion, instruments, or I/O, will use. It has the communication aspects, it has the information modeling aspects that are in the specification, and it also works on facets and conformance units and how we relate and what we require. So it's really the core piece of the functionality for UA FX. And we have a very good team of people building it, so I have to chair a bunch of very active people that help figure out what we want. So the base facet working group is largely done with the core pieces. At this point, we have maintenance releases out. We have one coming out shortly where we're adding some functionality. That's for controller-to-controller. Now we're going to go to controller-to-device, so there'll be some more new pieces for the device models. But mostly it's there. We don't have a lot to add, but we'll come up with some topics to add. And part of the sitting meetings we have here is we're working more on the C2D aspects, so the device aspects. So I spend a lot of my time here learning and listening to what's new and what we'll need to add. And we've come up with a few things I'm going to have to add into the base facet spec for devices. So some new pieces.
So currently, I chair the UA FX Networking Working Group, where we are introducing a new level of quality of service. This approach targets cyclic and so synchronous and isochronous communication patterns, expanding the application area to meet these requirements, down to the sensor level, to the motion drives, to the I/O devices. To address these needs, we use the latest IEEE standards, which provide special mechanisms to optimize resource allocation on the network layer. This enables real-time and non-real-time traffic to coexist on the same wire, on the same network. And this is a very new technology. We are working on several additions to this specification. One part defines new options for resource allocation on the network layer, supporting communication which guarantees limits for latency and jitter. And another very important part standardizes the bootstrapping process for the UA FX devices, which is also very important for automating the commissioning and device replacement to reduce the human interaction which is necessary handling this new technology.
For me, I was thinking that from control to controller to control to device, that maybe the enthusiasm will decrease, but it didn't. Actually, I think it's even bigger because now we are closer to the goal, and so people now are a bit accelerating. So at the end, it's very good atmosphere and very productive atmosphere.
I would say since 2022, we're on a good track. We released the controller-to-controller release, the specification. We issued last year maintenance release for C2C. Now it's a regular process, and C2D is ongoing. So controller-to-device specification. Well, I think we're on a good track with that.
We are trying to define a device profile that targets motion devices based on the underlying OPC UA FX technology that offers real-time communication. We are addressing a large range of devices, starting from a very small standalone encoder towards a standalone power supply, frequency converters, servo drives, until modular systems consisting of I/O modules and motion modules, which offer a huge complexity to handle. The challenge is to model this large variation of devices, but we also want to do that. We are starting with electrical motion, but we are open towards for later integration for pneumatic and hydraulic motion. That's one target. The advantage is that we are building this on the OPC UA information model, which offers us a very flexible model, an extensive model where a lot of companion standards and experience already exists. And we have a good team that helps us to find the best approaches. So the decisions we have made here in the group that definitely have an impact on the further specification for the motion profile is that first we realized we should start defining profiles for different types of devices. This was a learning from the C2C spec to do that rather earlier than later. So what we will do is define mandatory functions, concentrate on the core components of our motion profile, and get these things solved very immediately.
But now we're moving into, we're finishing kind of the first phase of the project, if you will, and that was the controller-to-controller communications, and now we're beginning to work on controller-to-device communications, and I'm pretty much a domain expert in how device communications worked in the process automation industry. So, and we have a working group for that. The instrumentation working group is pretty much focused on process automation instruments, and so now in that context, I'm providing technical input, right, and things. And actually now I would say I'm really the primary editor for the instrumentation specification. So like designing, proposing information models and behaviors and things like that. So when it comes to devices, all right, there's two primary, well, there's kind of a spectrum of from process automation to factory automation, right? So on one side we have the instrumentation working group that I'm heavily involved in actually contributing to, and then on the other end there's a motion working group, right? And they've been active for quite some time, actually, longer than the instrumentation working group, but and that's pretty much purely factory automation. And then sort of in the middle there's an I/O working group, which is, and so in the instrumentation working group, we have a proposal for how we're going to do a particular function, which is diagnostic configuration and enunciation and things like that. And so that was part of what we presented during this meeting, with the goal of coming up with something that can be used in a general sense across all devices, right? So something that would be satisfactory for factory automation and motion, right? So that was, I got good feedback on that. It was essentially, accepted. I mean, there was no complaints about what we were doing, although there were some additional constraints that motion really places on what we're trying to do. And so I'll be thinking about how to address those, come up with a compromise that addresses those needs as well.
So we've released Part 83 completely to the public. So all of our controller-to-controller work is largely finished, and we're moving on to controller-to-device work. We've got a lot of effort behind the constraint language and how to use the constraints, how to support constraints in offline engineering. And we've got a general agreement now on how to proceed. So the next step was to implement what we've already done, to develop guidelines in order to be able to use the descriptor in a more easy manner, more simple manner, and to include functionality for multiple family of devices and modular devices.
Then another important topic is to work together with TIAC, which is responsible to define the conformance test spec for 6802. The TSN profile for industrial automation, and that OPC Foundation can integrate it also in their certification program and can use it for the TSN testing TSN aspects.
As someone may know, the development of FLC or UA FX standard was divided into these two phases, C2C and C2D. Yeah, so is the prototyping. So when we started, the group is mostly attended by controller vendors. And we prototyped features such as connection management, configuration, diagnostics, security. They are all mostly related to C2C. But we still have two more items on our roadmap for C2C. And one is the application of base network model, which is the OPC UA Part 22. And its corresponding priority-based quality of service mechanisms. And the second item, still remaining for C2C, is the application of the log object. That's a new concept in UA, which we'll use for advanced diagnostics of UAFX systems. And then when this is done, we are ready to move to C2D, which I'm sure will bring us a lot of exciting challenges. So maybe one thing worth to mention is that in C2C, the communication is done based on non-time synchronized PubSub over UDP, while in devices we will start talking TSN. So this will bring a lot of new areas for prototyping, definitely. We also have all of these classes of devices like high-speed motion devices, the very complex remote I/O systems, but also very small and resource-constrained field instruments such as temperature sensors and so on.